In our last video, we integrated an odd function over a symmetric interval, an interval that goes as far left as it does right around the origin, and found out the answer was 0 and the answer had to be 0. But along the way, we saw the graph of f of x equals x root times the square root of 4 minus x squared. And so what I want to do now is, instead of integrating from minus 2 to 2, I want to find the actual area shaded here. And so when I integrate, this comes out negative, but it's a shaded area. I should be able to find it in this nice happy shaded area over here. So I could think about doing two different integrals, right? Integrate from here to here and change the sign. Or I could realize that this area and this area are actually the same because it's an odd function. It looks the same if I rotate it around the origin 180 degrees. So what I'm going to suggest is we just find this area to start and then multiply that answer by 2 to find the total shaded area. So I'm going to focus in on just finding half the area, and then to state my final answer, I'll multiply it by 2. Well, that's just the area under a curve in the x-axis. So I can just integrate from 0 to 2 and see what happens. Well, I don't even have to think that hard. All of this work still holds up pretty well, right? I'm going to do the same substitution, and, well, I'll find this area. All right, so I've done the same work over again here to prepare for the substitution. I know the x's are going to cancel. In fact, apparently I knew it here because I'd already left it off, du over minus 2x. But the x's are going to cancel, leaving me with the square root of u times du over minus 2. Already thinking about those x's having canceled. Let's go on and find the bounds. Plug in a 0 and get out a 4. Plug in a 2 and get out a 0. And so now what I have is minus 1/2, the integral from 4 to 0 of the square root of u, or u to the 1/2. Well, a lot of students will pause at a problem like this because these bounds seem out of order, but that's fine. We know how to handle that. I'm in fact going to go on and change the bounds, and that changes this sign using the order of integration property from earlier in the course. And so now I have a pretty easy antiderivative to evaluate. I have 1/2 times the antiderivative of u to the 1/2, which is 2/3 u to the 3/2, evaluated from 0 to 4. I'm going to go on and multiply the 1/2 and 2/3. I'll get 1/3. I'll still have that u to the 3/2, evaluated from 0 to 4. All right, and now we can evaluate. So I have 1/3 times, if I plug in a 4, well, that 3 over 2, I can think of the 1/2 part of that as a square root, so I'd have 2 raised to the third is 8. Plug in a 0 and get out a 0. So we get 8/3. And so this green shaded area up here was 8/3. To find the total area, I need to double it. Oop, writing off the screen there. The green shaded in the total area, I'll just double it, and that's going to be 16/3. So that's that total area shaded.